Lab 5, Analog to Digital Conversion. In Lab 5, what we'll be doing is investigating the analog to digital conversion that occurs inside our Arduino Nano. The components that we'll need for this lab are 3 LEDs. We're going to need 3 300 ohm resistors. We're going to need one 10K resistor, an LDR, which is this guy, and you'll notice that it's got a little squiggly line on the top there. That's the resistive element that changes resistance with the amount of light that's hitting it. We'll need a little speaker, and also notice that there is a little plus symbol that's on the speaker, so that little plus symbol tells you that that's the plus pin. It's also written on the bottom of it as well, so if you have a look at the bottom, you'll see where the plus and the minus are on the bottom down here. And we'll need a potentiometer. Now, a potentiometer is a variable resistor. It has 3 legs. Between the outer 2 legs, we have, in this case, 10 kiloohms. The B in front of the 10K that's written there on the top of the potentiometer, that B that's written on the top there indicates that this is a linear taper on the resistance change. And so as we turn this knob, what ends up happening is there's a wiper that wipes around the potentiometer, the conducting ring within the potentiometer, and makes contact at different points. So when our knob is all the way turned in one direction, the center here connects directly to this left pin. When we turn it completely clockwise, the center connects directly to the right pin. If we're in the middle, so we're in the middle mark, the center, the resistance between the center and here will be 5K, and the resistance between the center and my right side will be 5K. Total resistance though, between 1 and 3, so our left to right pins, remains 10K. Looking inside the potentiometer, so if we take the back case off the potentiometer, you can see that we have a set of wipers. That's these little fingers here. You see that there's a double group of these little fingers, and they wipe on that grey material. That's the resistive material. Okay, that resistive material changes its resistance well, as it goes along. So the more of the grey material that's present between the wiper and one of the pins gives you a larger resistance. So when I have the potentiometer sitting in the halfway mark, you'll notice that the wipers are sitting at the center of the potentiometer's position, and it's sitting at the center of the position. That means that we have half of the resistance on one side and half of the resistance on the other side. Again, we haven't changed the total resistance, so between our 2 outer pins it still remains 10K for this one. Okay, and we'll need some hookup wires as well. So what we'll do now is we'll construct our circuit as per the lab notes. So we are to hook up some LEDs to pin 5, 6 and 7. Alright, so D5 to our first LED, D6 to our second, and D7 to our third LED. And connect a potentiometer up to the analog pin 3. Okay, so we'll put our potentiometer in over here. Now we've got 3 legs on our potentiometer, so we're going to wire them up so that we have one of them connected to our 5-volt source, which I'll do it as my left leg. The other side will be going to ground. Connect that directly over to ground. And the middle one will go to our analog pin 3. So that's A3. A3, there we are. That goes into the middle pin. Okay, so we have 5 volts on the left, the middle one is to A3, and the right pin is going to ground. Let me hook up my 5 volts power. Okay, I'll make this a little neater. Is we will have our microcontroller, and we're going to connect from our microcontroller to the center of our LDR. Okay, so they're the little symbols of photons hitting LDR. This side will go to ground, and the other side will go through a nice big resistor, which will be a 10K resistor, and this will be at 5 volts. Okay, so that's what we're going to hook up, and this is going to go into our A2 pin of our microcontroller. So we'll grab our wire, and we'll have that come over to the top over here. So our A2 is going to connect to one side of our LDR. Here's our LDR. We're also going to connect in our 10K resistor. And one side of that 10K resistor is going to go to our 5 volts. And the other side of our LDR is going to go to ground. Okay. So we've now hooked up our LDR. We've also hooked up our potentiometer and our set of LEDs. And the final thing that we need to do is connect up our little speaker. So the positive side of the speaker, what we're going to do is we're going to connect that up to our 5 volt rail, and the other side of our speaker is going to connect into the pin that we're going to drive it from. So I'm using the connection points down here on my board. So I've got one side going into the positive, and the other side I'm going to go into pin 11. So we've got pin 11 over here. I'm using a brown wire for that. Doesn't matter what color wires you use. I try to keep things fairly consistent though. So red for 5 volts and black for ground, and every other color for signals. Alright, so we're wired up for our lab. Let's start writing some code. So let's write the code to set up the pin definitions for our LEDs, our pot, our speaker, and the LDR. So we'll do this by writing in all of the pins. So int, we're going to say LED 0 is equal to, we're on pin 5. We're going to have LED 1, 2, and 3. So 1 and 2. This is on pin 6 and 7. We're going to have our speaker call it buzz for buzzer, and that will be on what do we got that on? Pin 11. LDR is on pin 2, A2. So int LDR equals 2. Okay. So we should be right. So the second part of part 2, we need to write some code to set up a serial monitor so that we can monitor values straight into our serial monitor. So we need to have, in our void setup, we need to set up our serial control. So we will have serial dot begin, the baud rate 9600, and we can prove that this works by writing down in our void loop. We can write into their serial print line, and we can write hello world. Okay, let's plug in our Arduino and give that a go and make sure that that shows up. Column. Right, to open up the serial monitor, we just go over to serial monitor. Make sure we have the correct baud rate selected. And there we go, hello world, hello world. Excellent. We'll close the serial monitor. And we'll move on to the next part of the lab. So underneath our void setup, we need to set up our pin directions. So we use that using pin mode. And we're going to have this as LED 0 is our first one, and that is an output. And we also have our buzzer. And that's all we need to actually set up for that. Our LDR and our potentiometer. Oh, we forgot to put our potentiometer in here. That's A3. Excellent. Part 3, serial logging. For this, what we're going to do is we'll read in the analog value of the potentiometer and read in the analog voltage of the LDR, and we will write them out onto our serial port. So we'll write them out in the manner of pot, colon, the number, comma, LDR, colon, then the number, and then the new line. So to do this, we will need an extra set of integers. So we're going to have in here the integer value for our potentiometer ADC value. I'll set that to equaling 0 at the beginning, and we'll do the same thing for the LDR. Okay, so we've got two integers that will store the values of what's being read in from the analog to digital converter. That's connected up to the potentiometer's center pin and the middle pin of the LDR and the 10K resistor, and the junction between the two. So we'll start off by reading in the analog read-in. So we're going to read in the value of our LDR and of our potentiometer. So underneath our loop, we will have the hot ADC is going to equal the analog read of the pin being the hot. And cut and paste that below and change it over to our LDR and LDR. So this will read in the two values and store them into this integer. Okay, so it'll read it in for each pin, store it into the integer. Then what we'll do is we'll display that out in a series of print lines. So the first thing that we're going to do is we'll display pot colon space. I'll copy this. Next thing that we'll display is the pot ADC value. We'll have a space after that value, and this will be the LDR, and the final one will be the same as this line, except that'll say LDR. At the end of that, we want to print to a new line, so we'll do LN. Alright, let's upload the code, open up our serial monitor, and there we go, we've got our potentiometer value. Let's change our potentiometer value. So you'll notice that that's changing as I'm turning the potentiometer down. So I'm at 0, and then all the way up to should be 1024 or 1023. We're almost to 5 volts, but not quite. Okay, and my LDR sitting at 90, 92, 97. Let's cover it up. Oh, look at that, we've gone up to 371 and in some light there. And maybe if we have a bit of bright light from mobile phone, maybe it'll make it even brighter. We'll change the value. Do we go? We're going down even further, so we're down to 1920 or so. Okay, so that seems to be working. Excellent. Now obviously if we change this 10K resistor to being a different value, that'll give us a larger range of operation that our resistor divider network here will operate at, and you can investigate that in your own time. So we're done for the serial logging part there, except for the fact that the message should be sent every 400 milliseconds. I've got it set to 500 milliseconds, so we'll change that to 400. We'll re-upload, and then we should be correct. And there we go. Actually, there is something else that I forgot as well. I forgot to put the comma in after my first value, which I can edit that by putting the comma in just here. There we go, we've got the comma. Now it should look exactly the same as what we have in our lab sheet. Yep, there we go. Excellent. Part 4, LED voltmeter. So for this section we're going to use our 3 LEDs here to show the voltage that's being applied to our pin 3 of our analog input on our Arduino. So we're going to program these up so that each one of these LEDs turns on at a specific value. And to do that, we're going to alter our code from the previous part, obviously saving it and making our changes later. So what we'll do is the read-in value that we get from the potentiometer is going to be used to drive our LEDs, and how we're going to do that is we're just going to use a series of if statements. So if pot ADC is less than 200, or let's say 333, that's 1/3 up, so we've got 3 LEDs. Then we'll turn that LED on. So this is digital, right, LED 0, and we're going to say that's a low. Close the bracket, else we'll have digital right high, so that turns the LED off. Don't forget my semicolons. Close off that else statement, and we'll do the same thing again now for the other cases. So the next case is if it's greater than 666, then LED 1 is on, and our next case will be if it's greater than 1000, LED 2 will turn on. So we'll only get to 1024, so this LED will only really turn on when we're at the full maximum turn of the potentiometer. We'll separate these out nicer a little bit later. And I'm going to put in here at the end of, I'm going to change my display. I'm going to add some extra functionality in here. So I'm going to display a few things on the on my serial line. So a few things that I can display on my serial line is whether or not I've turned on certain LEDs. So if LED 1 or 2 or 3 or have turned on, or I should say 0, 1 or 2 have turned on. So if these LEDs are turned on, so this one here, I can display an on, so I'll do serial print, copy that. This will be on. And the same for this one. Same for this one. And for these ones, it'll be off. And because this is the last one, this is the line return on both of these. Only one of these will be executed, right? So it'll either be this case or this case. So we put the line returns on both of those, so that we're guaranteed that at least one of them will be tripped. Let's upload it. So we'll check, go all the way up and all the way down, and there we go. So we're driving everything here correctly. Let's have a look at our serial monitor. So everything is off, yes. We have one of the LEDs on, yep. Our first one is on, which is correct. Our second one turns on, yep. And then our third one turns on. Excellent. So to change our operation now to being the other direction, what we can do is we can close our serial monitor, we can go into here and we can change these as being the opposite signs. So instead of having less than, we can have greater than symbols. Oops, got to get rid of the other one. And we'll have a look and see what our operation looks like now. So we have an ADC potentiometer value that is full, and we've got all our LEDs turned on. As we ramp back, we're removing one of our LEDs as we go. So you'll notice that the value is now decreasing, and we're done. Now, just for fun, let's add a few more LEDs and see if we can get this voltmeter to be a little more precise. So we'll add in an extra set of LEDs. And we'll drive them from D8 and 9. So we'll alter our code to take care of D8 and D9, and so we'll grab another 2 LEDs, copy that. So this will be LED 3 and LED 4, pin 8 and pin 9. We need to also include them in our pin output control. And we need to add an extra set of these if statements, an extra double set of these if statements. Which will be for LED 3 and LED 4. And so what we'll do is we'll say 1024, we'll say it's close enough to 1000. Let's divide that by the 5, so it's every 200 steps. So we will have our first one being 200, second one being 400, third one being 600, fourth one being 800, and the last one being 1000. Alright, let's write that. Now, we do need to get rid of these extra line ends, line returns, otherwise we'll have too many new lines in our code that gets printed out in our serial port. Okay, what have I left out? I've left something out. No lead 5. Oh, I don't have a lead 5. It's the 5th lead. It's lead 4. There we go. I'll open up our serial monitor and I'll go and have a look at what we read in. So we've got 200, 400, 100 count, 800 count, and 1000 count. Excellent. My simple voltmeter works relatively well. So for the remaining parts of the lab, part 5, 6 and 7, you can draw on the previous labs that you have completed and write the code to PWM the LEDs so that you have a brightness control that's controlled by your potentiometer. So read in the value that's on your potentiometer, and from that value divide that down so that you can get that in the range between 0 and 255. So you need to divide that by 4, and that'll enable you to drive the LED. For the brake beam sensor, part 6, you're going to use your LDR and an LED, and if you set your LED to turn on, you should have it on continuously, and if you break the beam, you should be able to see that your indicator LED turns on or off, respectively. So the final part is the buzzer alarm, and that's based on the previous question. So not only will you turn your LED on or off as your indicator, but you'll also have to send a PWM of 50% duty cycle to the buzzer, and we did that by doing an analog write to the pin, which in this case it is on D11. So you'll do an analog write to that at being 50% duty cycle, and the 50% duty cycle, 0 to 255, will be 127. So you send 127 to that pin, and then you're done for the lab.